Morning. We're starting quadratic equations formula today. Alright, looks like we're starting directly with a question because majority of the questions can be solved in the section can be still solved by what you learned from previous chapters, like chapter 6 and the chapter right before this, chapter 10, radicals and square root property can solve this question. So I will first try to attempt solving this question by old methods, see where the difficulties are arising, and see why we need a new, better method. Okay? So we are not starting quadratic formula yet. Let's think about how we used to solve this question from chapter 6 methods. In chapter 6 you have seen this kind of trinomials. It's called trinomial. It has three terms. Technically this is called the quadratic equation. Quad means squared, square equation. You have a term with a square x and minus 65. What is the most primitive, actually most efficient way to solve such questions if you're lucky? Sometimes that if that method works, that can take care of the question in maybe 30 seconds. So first thing when you're presented such a question is to do that method. What is that method called? What do you do? Yeah, set two parentheses and try to part this equation into two pieces. This is called factoring. This is called factoring method. We learn how to factor these things in chapter 6. So we first tried chapter 6. You try to break x squared into x and x, and then all you need to do is guess what two numbers multiply into minus 65 but add into 8. They will also must add into 8. Two numbers multiplying into minus 65 adding into 8. Can you do this on top of your head? Find such paper. Negative 5 and 13 works perfect. Negative 5 and positive 13. Look, 5 times 13 is 65. Negative plus makes minus 65. Check. Add these 18. Take away 5. 8. Check. We are all good. So this is a 30-second question. All numbers are picked well. So we were lucky. And all you need to do is now set each piece into 0. Factor and set it into 0. That's the method we do in chapter 6. And you get x equal 5. Just add a 5 to both sides for this. Then subtract 13 from both sides. You get x equals minus 13. This is how we do this in chapter 6, called factor and set 0 method, let's say. Okay, we learned something in chapter 11.1, the previous section, actually last week. We learned how to solve these equations by completing into square, remember? And this question almost look like this. So I'm going to take this method from last week. You can also do this same question by this method. Same thing. Look, you have x squared plus 8x minus 65. All you need to do is turn this trinomial into a square, set it into a number. That's it. I need to turn this into a square and set it into a number, but that wasn't easy. We have to follow these steps to achieve that. How do I do that? First, we check out the number in front of x squared. If it is not 1, we need to divide all sides by that number. But we are good here because it's already 1. You don't have to do step 1. You don't have to divide both sides by that number. Step 2, isolate the variable terms on one side of equation. That means the number must travel to the other side. Variables should stay on the left, number must go to the other side. So I'm gonna add 65 and send it to the number to the other side. And now this space is vacated. nothing, and the other side has gained some numbers turned into 65. 0 plus 65, 65. That's step 2. Questions so far? Step 3, we are going to find out a number that's going to turn this into a perfect square. So you need to find the number n here, add both sides by that n, okay? And it's going to make this thing a square. So what is that number going to be? 16, the number. How? We take half the middle number. So again, you take half of it, 4, and square it. Square it to find it. What is 4 squared? 16. And I put 16 to both sides. Okay? So this side becomes 65 plus 16 is 81. But this side turns, this is called a perfect square. Now, perfect square, this can be made a square by a number here, which is, what is that number? Where do we get that number from? It's this number always, half the middle. Yes, it's 4. Or square root of this number, 16 square root is 4. Because when I square it must make 16. And that's it. Step 4, apply square root property. What is square root property? Square root property basically says take square root of both sides. But when you do that, you put plus and minus option to the right side. And you will split this equation into 2 cases. Case 1, the positive option. Case 2, the negative option. Again, square and square root cancels. That's why we're applying square root property to cancel this square. And we have only x plus 4 on the left sides. But on the right side, you have 2 options. Positive 4, positive 81, root 81, or negative root 81. But what is root 81? 9. This is minus 9. Are we done? You need to isolate x. So you need to subtract 4 from both sides. Hence, we have 5. And for 9 minus 4 is 5. Minus 9 minus 4 makes bigger negative, minus 13. Do we have a match? Same answers? Look. Same thing. Different method. Chapter 6, Chapter 11, first section. You can solve this in 2 questions. Fast. And this is long. It's not slow, right? This is slow. But both methods work. But this is a little bit tricky. There are steps you can fail, you can make a mistake. So if you are given a chance, if you're offered an option, I would go with this. Well, what is the third method we are going to learn today? It's called a formula. It's named quadratic because these equations are quadratic equations. They call it quadratic formula. I'm going to solve this question by that third method, new method, and you will judge. Whichever method you like, you go with it. But sometimes some questions you can only do one way. The other two are either too long or impossible. But this quadratic formula I'm going to present next solves any kind of question. So this is the most superior or most efficient one, most strong one. What is the right word to call this? Powerful. It solves any question. But just because it's most powerful doesn't mean you need to use it, right? I mean, would you use a rocket launcher to kill a fly? It's like that, okay? So it's powerful but dangerous to use. So try to avoid it. If you have an option that if you see it's factoring, do this first. Do fast method first. This is safe, most safe, because it has so little steps. Look, you just have 1-2 steps. It has so little set, so this is safe, fast, but it's vulnerable. This is a weak option. Sometimes you can never break these, right? Okay, so sometimes you can never figure out these two numbers. So this is weak but safe. This is strong, powerful, solves any kind of question, but it's dangerous. Where is the danger happening? Because you guys mess up computing this square root most of the time. I mean, you think you did this question right, but answer you get is always most of the time wrong. Trust me, unless you're using a calculator. Yeah, and even you're using a calculator, you pick the wrong order of operations and you mess up again. Okay, but let's do it. Let's see where you can mess up this question. Again, same question, which you're gonna go with the quadratic formula. It says, quadratic formula says, first record or find out the numbers, 3 numbers. You need to first find out and write 3 numbers. They come from the number in front of x squared. You need to find it out. The number in front of x and the number, constant number. You need to find and name them. And all you need to do is enter those numbers into the spots designed in this formula. A and C goes under the square root, and A also goes below the square root in the denominator. B goes into 2 spots like A, one under the square with a square, under the square root with a square, and one outside with a minus. C is only used in 1 spot. It's right here under the square root with A. You multiply it and put it there. Again, minus B plus minus square root B squared minus 4AC over 2A. How many of you guys have seen this formula before? Raise hands. Okay. Almost everybody is familiar with this. Let's apply it then. Okay, I'm gonna do it right here. Somebody read me what A, B, and C are so I can substitute them right here. I will just do it here. What is A? 1. I have nothing in front of x squared, that means it's 1. What is B? C. Yeah, these numbers go with the sign in front of them. So this is positive 8, and this is minus 65. Oh, not 64, 65, right? Alright, let's put them back in place. I see a fraction first, a long fraction, minus B. This is 8, so it is minus of positive 8, it's minus 8. Minus of positive 8 is minus 8. Kind of flip the sign of B. If this is positive 8, it becomes minus 8. If this would be negative 8, you would call this positive 8, or opposite. Plus minus coming up next. A big square root. We're gonna fill up the square root with 3 numbers inside. B squared is first, so it is 8 squared minus 4. A is next, which is 1. C is 65. Am I right? Yeah. If there is a negative number in place, put it in parentheses. Over 2 times 1. Right? A is 1. Showing up one more time in the denominator. Okay, let's continue. You can't just leave your answer like this. You need to compute this thing. Simplify as much as possible. Alright, where do we start? Start always from inside the square root. First find the square root. So this is your target. This is first needs to be tackled. Don't try to cancel 8 and 2. Don't do it yet. First, handle this. For in the inside of the square root, where do we start with first? Compute this square. That's 64, 8 times 8. And then compute this triple product. 4, 1, and minus 65. Do not do this. Here is a mistake. You notice quickly this is 64. And you see, oh, there is a minus 4 coming in after 64. You subtract 4 from 64. It's wrong. You cannot perform subtraction here until you clear all power and multiplications. In order of operations, power is first, multiplications next. So once you compute 64, you need to get this triple product. 1, 2, 3 numbers must be multiplied. So there are 3 numbers here. Minus 4, positive 1, minus 65 will all multiply each other. Like, remember, don't forget to multiply the sign in front as well. Minus 4, 1 and minus 65 makes, take a calculator and do it if you want. But this is negative, positive, and negative. The answer will be positive. Look, negative times positive is negative. But negative times negative is going to make positive. So the result is going to be positive. 4, 1, and 65 is 260. Yeah, you can multiply the bottom. 2 times 1, it's 2. But until you don't do anything else until you compute the square root or simplify the square root. And now there is only one operation left under the square root, which is addition. And they do make 324 when you add, right? If possible, compute square root of 324 by a calculator, if possible. If you're getting a whole answer or terminating number, do it. So I will check my luck. The number terminated, so I can use it. But if this was 325, let's say, don't use this number. Because although it looks like terminating at 3, it's not. So when you take this number, you are approximating it, rounding it off, which is not going to be exact answer, and you will get an incorrect result. If it's not terminating, don't take square root. But if it is terminating like this number, use it, which I'm gonna use. Just 24, right? Is it? No, it should be 18, right? 24 is too big. Alright, at this stage, now you have one number on the left, one number on the right. You're done with the square root. You are going to split your answer into 2 cases because there are 2 options here, positive or negative. So you will first write one option on the top and the second one on the bottom. So I go with the positive option first and the negative option second. Add minus 18 and positive 18, making 10. Divide by 2, result 5. Add minus 5 and minus 18, minus 26. Divide by 2, minus 13. And we're done. X equal 5, x equal minus 13. We have just solved the same question by the third method and got the same answer. So I'm pretty sure we have this result correct. So you go ahead and do minus 13 comma 5. Okay, so comparing these 3 solutions, which one is the fastest? Get to the result quickly. course this one. Safe, fast. But this is weak. Sometimes you can never break those numbers successfully, so you quit and go to the next step. This is too long and weak as well, so you rarely use this method. I would go switch to quadratic formula. Again, this is long again. Look at how many computations we made, and they're dangerous. You can make sign mistake, square mistake, order of operations mistake. There are so many ways you can make mistake, but you always get to the result if you do the right order of operations. No mistakes, no computational mistakes. Okay? Any questions? Alright, in the remaining 3 questions we will do the same thing. Apply quadratic formula. Alright, I will give you 2 seconds or 2 minutes time. Try to solve this. There isn't any special tricks. Alright, do you all agree on this answer? Let's see. Let's read the numbers first. A, B, C. What is A? 4. The number in front. B, the number in the middle. C, -5, right? Okay, let's substitute them back in the equation. Minus B, so it's minus 19. B is 19, so I see minus 19. Agree? Yeah, it's negative of negative 19 means flip the sign of negative 19, positive 19 this time. Still plus minus, long square root. I will fill in this next. It is B squared, so it is minus 19 squared minus 4. A is 4. If it's positive, you don't need a parenthesis. C is negative, so I will keep a parenthesis around it. So this is again a negative number, a positive number, a negative number multiplication. The result will be again negative, positive, negative multiplies into negative. What is negative times positive? Negative. Negative times negative is positive. So the result will be positive. Okay? So 19 plus minus 19 squared is, what is it? 361. Is that right? And now 445. 4 times 4 is 16. 16 times 5 is 80. But positive, we have already discussed that is positive. Over 2 times A. What is A? I forgot A. Look, 4. What is 2 times 4? 8. Okay. Are we good? What's wrong, Chris?
361 plus 80.
361 plus 80? Yeah. So it is 4, what?
41.
41. Is 441 is a whole square? Can we compute that? Yes, we can. So you're lucky on this question too, which is 21. And now it's time to split this answer into 2 parts. This x is either the positive option or negative option. That's 40 over 8. That's a 5. However, when I subtract, drops to negative 2 on the top. Well, they still cancel. Divide both sides by 2 and we get -1/4, right? Seems like we got the same answer, 5 and -1/4. Okay? I'm just wondering if they will like the -1/4 as decimals. So -1/4 is -0.25. Yeah, still accepts. Because I know some of you guys still use a calculator here and get a decimal answer. But this is sufficient. You don't have to turn it into here. If you do, it still accepts this. Okay. As long as it's terminating, you're fine. 0.25, 2 digits, fine. Alright, a new question. We need to first name ABCs. I see 1 in front of Z square, so that's A. The middle number is positive 19. The last number is positive 10. I see 10. Am I right? Or am I doing it this right? No, it's not where you see the numbers, it's where the variables and things are. So B is the number in front of the variable with X or Z. So your B is not 19. It should be, A is correct though, A is 1. B is the number in front of Z, so I'm saying it's positive 10. C is the constant number, it's positive 19. Am I right? I'm still wrong. Why? Right. We need to first make this in standard form. In other words, the right side must be 0. Everybody, all numbers and variables must travel to left before deciding ABCs. So this question is not ready to call ABC. We need to first flip this guy to the left, to the midway, right in the middle, so we can put it in standard form. So this is Z squared minus 10Z if you subtract 10Z from both sides, okay? Minus 10Z. Minus 10Z comes to the middle, and positive 19 is the third term. Now we have 0 on the right. This is standard. We can name ABCs now correctly in this form. A is 1, B is minus 10, Z is positive 19. Okay? That's one common mistake. Happens. Next, we plug them in. Minus 10, negative of minus 10 is positive 10. Plus minus 10 squared minus 4 AC. Next time positive, negative multiplication. Negative, positive makes negative. Yes, 2 times 1. So I'm expecting a negative subtraction in this under square. Minus 10 squared is minus 10 times minus 10. This is always positive, 100. Take away 4 times 1 times 19 is 76 over 2. Okay? Alright, we have a simple subtraction going on there, here, 24. At this stage, we used to always compute 24 by a calculator. Let's see if we're lucky this time. I don't think so. This is a non-terminating number, so don't use this. We can't compute it. So are we gonna leave our answer like this then? So you have two options. X is either positive, no, sorry. The positive option, 10 plus root 24 over 2, or X is negative 1024 over 2. Although this is correct, it's not in the desired format the question requires. It says simplify this as much as possible. I don't think this has been simplified. I want to test it anyways. Let's test it. 10 plus square root 24 over 2. Oh, this has to be plus. You can put here plus minus and save time. Plus minus. Let's see if it's gonna like it. It says incorrect. Because the reason is, although the answer is correct, it's incorrect because I didn't simplify it. What do I mean by simplify? Because this is look like a big factorable number. You can break it. Maybe you can save people out of this prison. I know I can't compute it, but maybe there are parts of 24 that can come out. So can you break 24 into factors and see who's coming out? 2 cubed and 3? Or 8 and 3 first, right? And then 8 is 4 and 2. And then 4 is 2, 2. Yeah. It's locked, and now locked. 2 cubed and 3. This thing. So I can save at least one of 2's because you have $3, you pay off the guard $2. So 1, 2 will come out, 1 will remain. Again, how do we do this? You divide 3 by 2, it goes into 3, and then 1, 2 left, 1, 2 out, in. So the result is 10 plus 2 out, 1, 2 out. There is still 1, 2 remaining, which is gonna be 2 times 3, 6 though. So can I combine this again? 2 times 3 into 6 over 2. And you don't have to show this one here. Or you could have done this 24 as this is 4 times 6, and 4 comes out as 2. This is alternative option. If you see a whole number 4 as a factor, you can bring it out, and 6 remains because 6 is 2 times 3. It doesn't have a perfect factor. Okay. So is this answer now gonna be accepted? Still?
After you divide.
Oh yeah, we are gonna. What's that? Okay.
Would you divide first and then just do plus or minus?
We still have one more cancellation happening. So you simplified this part, but the question is, can I simplify this ratio? Can I divide 2's here? Yes, you can. You can divide 10 by 2, make this 5, 10 over 2. And are you gonna leave the other part as the same, 2 root 6? No, you need to also divide this part by 2. 2 and 2 will cancel. So you no longer have a 2 in front on a root 6. 10, half of 10 is 5. Half of 2 root 6 is just root 6. So this is the best answer you can put this result into. So same thing happens here. This is 5 root 6 with a minus plus. So you can combine them as 5 plus minus root 6 and try in here. Okay, now it's accepted.
Is this one of them that you could not have done chapter 6 method? That's what I tried to do clearly.
No. Chapter 6 method can only be done, well, I don't think you can break these into 2 pieces with the right pairs. Look, this is z and z. Are there any 2 numbers multiplying into 19 but adding into minus 10? 19 is a prime number, so it only breaks as 19 and 1. So you need to choose one side 19, the other one 1, You can choose both negatives, both positive, but in either case it's not gonna make minus 10. Okay? Alright? So this is not factorable. If it's not factorable, we can't do this. Okay? As a matter of fact, if your answer has square roots, it can never be done by chapter 6 methods. Okay? So that's why I call this method weak, because it's not, chapter 6 method was weak. It only applies to certain nice numbers, but this quadratic formula solves every kind of question. That's probably why you see in high school only this method most widely, because it's that kind of does a question. You don't need the others, but we still need to show you how to factor, because factoring works in other kind of situations as well. Okay. Alright, this question next, but I don't see a square quadratic equations here. So this at least has a square. I don't see any squares here, so you need to first prep this question. So let's do that part together. In this question, you need to first multiply out everything, clear those parentheses by distribution, combine like terms, and bring this equation into a regular standard quadratic equation. So 5m times m is 5m squared. 5m times 2 is 10m. Minus 9m times m is minus 9m squared. 9m times 3 is 27m. There is a mistake. Where? Yep. This should be a negative. Why? Because it's minus 9 times positive 23. And you multiply, they make minus 27. Now I see a couple of like terms. These are like, correct? You can combine them. They make how many? 5 take away 9. Negative 4m squares. Alright, I have a couple more like terms, these two. They make how many? Negative 17. And what do I do with this number though? Am I gonna leave it like that? Yeah, it needs to come to the left as minus 15, because the right side must be 0. I need to bring it to this format, and I did it. All you need to do is read A, B, C's now and apply into formula. A is minus 4, B is minus 17, C is minus 15. Do it right here. You have 2 minutes. Alright, let's substitute these back in place. Positive 17 plus minus 289. I'm doing it faster. You see 17 squared is 289. Minus 4, minus 4, minus 15. Triple negatives this time. Negative times negative times negative makes negative. 2 times A. So it is 17 plus minus 289. I know the result is negative, but negative what? 16 times 15 is 240. Minus 8 in the denominator. 2 times negative 4. For the first time A is negative, so we have a negative number here. Well, 289 minus 240 is 49. And we all know square root of 49 is 7. So this turns into a nice question. You have 2 answers here. One is positive. The other one is negative option of the square root. This is negative 3. That is 10 over negative 8, right? And that simplifies to 5 over 4, negative 5 quarters. Yep, same result. Okay. So this is all. Any questions? Alright, we'll start the next section tomorrow.